In the previous assignment, you learned about some of the variables that impact gases. One of those variables was pressure, one was volume, and one was temperature. And some of you also noted that the number of moles of the gas also impact it. So right now, our next lesson, we're going to look at factors affecting the gas pressure. So the first one is the amount of gas, which is the number of moles, and that's abbreviated lowercase n. So number of moles is a lowercase n. And the more particles of gas in a container means that there's going to be more collisions. And more collisions mean that there's more higher pressure. So take a look at my two containers here. I have a low pressure container with just a few molecules of gas being contained inside it. So you can imagine that with a greater number of particles inside a container, there's going to be more collisions occurring between the particles themselves and between the container, the walls of the container, and the particles as they move in their straight line paths. So that creates a higher pressure. So in short, the more particles of gas in a container means that there's more collisions, which means it's at a higher pressure. The next factor is volume. The volume of a container. Remember here that your gas can fill any container. So no matter what the volume is. So you can't say the volume of the gas, but you can say the volume of the container that the gas is in. Gas will fill the volume of any container. When the number of gas particles stays the same, the volume of the container is indirectly proportional to the pressure. So if you increase the volume of a container, you decrease the pressure. We have our low pressure example here, I should say. And if you decrease the volume of your container, you increase the pressure. So notice in our two containers here, we have the same number of particles, but because there's more space in the larger container, there's fewer collisions. And since there's fewer collisions, you have a low pressure system. And in the small container, there's the same number of particles, but they have less space, so they have greater number of collisions. A greater number of collisions means an increase in the pressure. And the final factor that we're looking at is the temperature of the gas. So the temperature of a gas is a measure of its average kinetic energy. The higher the temperature, the greater the movement of the particles. This results in more collisions, and more collisions, of course, result in a higher pressure. So in our two containers, we have a container that's at room temperature, so it's got a relatively lower temperature. The particles are moving slower, and there's lower pressure in the container. However, if we apply a flame to that same container, we have increased the temperature. The particles are now moving much faster, which means that they're going to collide more with the container, and that creates a greater pressure.